Hello, good afternoon, all of you. Welcome to this LinkedIn Live interview brought to you by the Human Brain Project. This is actually the first of a series of talks where we're going to invite scientists, as myself, from the Human Brain Project to present our latest achievements in understanding the brain. And that's really one of science's biggest mysteries. And today we're going to talk about consciousness, which is really mysteriously mysterious. My name is Steven Laureys. I'm a clinical neurologist, research director at the Belgian National Funds for Scientific Research and director of the GIGA Consciousness Research Unit at the University Hospital of Liège. And today I'm very, very happy because I'm gonna discuss with my friends and colleagues within HBP, and that is Alain Destexhe, research director at the CNRS, director of the European Institute for Theoretical Neuroscience, and Marcello Massimini, professor in the Department of Biomedical and Clinical Sciences at the University of Milano. Please, Marcello, Alain, join this LinkedIn Live interview.
Hi everybody. Hi Steven. Great to see you. Hi Alain.
There you are.
Hello, Marcello and Steven. Hello, everybody.
So, guys, let's discuss the big challenges we face and actually with our colleagues of HBP. Let me maybe start with you, Marcello, Professor Massimini. We know each other, of course, for a long time now. And for me, what really stood out beside all your brilliant work, of course, in trying to reduce our ignorance, I think we can phrase it like that, when it comes to human consciousness, and our good friend Giulio Tononi, who came up with integrated information theory. But your brilliant idea to test that with what you developed as EGTMS, and you're in a better position than me to describe what you did in this famous landmark science paper 2005 in Sleep, where you hit the brain with transcranial magnetic stimulation and read it out with EEG, which actually made our team say, well, we want this for patients, and try to understand whether there's a capacity for consciousness there. Can you explain us in lay terms how that idea came about and how you still use it actually?
Well, thank you, Steven. The idea, as you know, because I have to say, yes, the key moment was when we did that in Liège together on patients. But the initial, the first attempt was in sleep. And the idea was to probe the cortical, intracortical capacity for communication of the brain directly, independently of sensory processing and motor output. And the idea was to do that by stimulating directly the brain, to do that by a causal perspective, engaging causal interaction, and then looking at the complexity of this internal dialogue. And so at the time, and still now, probably the only way to do that non-invasively is to combine transcranial magnetic stimulation, that is a way to directly activate cortical neurons, and then record this brain response with EEG. It's like a little bit like a radar. So we ping the cortex and then we read this return signal, speaking of the complexity of the internal dialogue, which is high when consciousness is present and low when it's diminished.
Thank you, which I think really permitted clinicians like myself to maybe become a bit more humble, and sometimes at the bedside, when people who had a very severe traumatic brain injury or bleeding or survival cardiac arrest, where after coma they evolved to these very strange, I would say, artifacts of modern medicine, what we call vegetative state. People waken up, but all the movements are reflexes, and some, as we showed, are actually minimally conscious, but by definition they can't communicate. And so to have a tool that can objectively measure what's happening in that brain, and that is independent of a motor output, even you don't need to understand language, as we depend on trying to find response to command at the bedside in these patients. So I think that has been tremendously important. And you, Alain, of course, with all your expertise, Alain Destexhe, we all know for the big added value in terms of the modeling, and your collaboration also with Marcello within the Human Brain Project, which actually now reminds me that all of us have we have different points in common. We are all excited about the challenge of understanding the brain and consciousness, and we're all in the wonderful Human Brain Project. But also, I'm talking here from Canada, from Quebec, where I know you started, also, Alain, and you, Marcello, with one of our big heroes, Steriade, at what is now the Cerveau Brain Center at Université Laval. But so it's incredible that both of you actually were here. And maybe, Alain, you can share a little bit of your expertise in this huge challenge of using smart machines and modeling, and trying again to reduce our ignorance when it comes to the brain and consciousness.
So thank you, Steven. Yes, it's very nice that you remind us the time that we were in Quebec, because we did at the time. Of course, when we look back in time, we think always that we were very ignorant. But at the time we were studying essentially sleep with electrophysiological techniques and modeling, and it was already a very nice challenge to use computational models to bring some insights into in vivo recordings, which were the specialty really of Steriade during sleep. And now, with the experiments of Marcello, for us theoreticians, we have something really extremely nice at the same time, and it's extremely challenging. It's nice because you see something with your TMS-EEG experiments that is measurable. You see a correlate of consciousness in terms of how the activity propagates across the brain, initially by comparing awake and sleep, but later anesthesia, and also patients in some various stages of coma, which is also the specialty of Steven. And for us theoreticians, it's a big challenge because first we need to simulate these states. For wake and sleep, we are there, I think. For anesthesia, anesthesia is not equivalent to sleep, and so we are still working on trying to simulate anesthesia, as you see. And the nice thing, as I was saying, is that there is this activity pattern that propagates in the brain following the stimulus, and it really differs between a conscious and unconscious states. And for us in the Human Brain Project, we have worked during many years in building the tools in order to be able to simulate and to try to understand how far we can explain this propagation of activity and as a correlate of consciousness.
Thank you for sharing that. It's definitely a huge challenge, and I think so tremendously challenging that it definitely needs, right, different disciplines. So we need the theoretical guys, modelers like you, but that's a whole bunch of people. I don't know, in your team you have a number of disciplines and mathematicians and statisticians and informatic.
We have a mix of a very large number of disciplines, and we even have philosophers. We had at some point.
Even philosophers. The same for you, I think, Marcello.
It's just to tell you that it's very open.
Yes.
Yeah, we do also have philosophers, and they're very useful, actually. Speaking about being humble, it helps a lot, actually.
So this I think is wonderful, that now science is getting rid of this kind of limited view where we had faculties, and I'm in the faculty of medicine, and so the medical doctors will need to understand what is possible in terms of new mathematical models and high-level statistics, neurobiology, and these people come from different backgrounds, and putting them together, I think, is also what in Liège with the Coma Science Group has been really added value. And of course, then at the European level, the Human Brain Project, putting together all these guys, also with the ethical implications, of course. We have Katinka Evers and friends where we think, how are we going to use this in our society today and tomorrow? So maybe coming back to you again, Marcello. So you developed this new test, one can say, which is EEG-TMS with a very strong magnet, transcranial magnetic stimulation. You have the MRI, so you can navigate in the brain. You know where you are, and you hit some spots while measuring. And I know I was there, how difficult this is technically. You read out the electrical echo response with EEG electroencephalography, and then you, with your team, calculate what you call perturbational complexity index, which is again very ambitious, right? Reducing consciousness, which is multi-dimensional, to one dimension, one number, and if it's below 30% or something, you saw it in deep sleep. It was different in dreams, right? You saw it in anesthesia. We did it together in Liège also with the different drugs, and Vincent Bonhomme, who's the head of anesthesiology, and then we looked at the patients. So where do we go from there? Do you see maybe we've been, of course, using functional MRI and positron emission tomography with the Coma Science Group in Liège and validating also your test. What are the other options, and how we could also learn from Alain Destexhe modeling work and trying to come back again to the clinical challenge?
Yeah, thank you, Steven. This is an important and complex question. So first of all, let me say that I've learned actually in Liège how important the multimodal approach is, and combining techniques and approaches to acknowledge the multimodal, really the multidimensional nature of consciousness. So this measure we're talking about, PCI, it's a measure that is very sensitive in detecting a capacity for consciousness, but it tells you nothing about the content. It tells you that PCI, if this complexity is high, the subject is somewhere and is somehow conscious, but it might be dreaming, it might be hallucinating, it might be conscious but disconnected. So you don't know that. So it's a first pass, let's say, it's a first screening. But then the challenge is, that is also very ethically and clinically relevant, is to also frame and try to define what kind of consciousness is in there. And for this, the technique is obviously not helpful at all. So there, you need to combine it with other measures in this multimodal, multidimensional framework. And for instance, spontaneous EEG might help. And there is this example, Steven, actually, that Olivia Gosri from your lab, together with Seong-Wan Lee and Mingji Lee in Seoul, they combine TMS, EEG, and EEG in this, say, multivariate machine learning framework. And already there, that was useful because by combining the two, you could have a distinction also within consciousness, whether the subject was dreaming or hallucinating, which is, of course, relevant for patients, and more. And then fMRI, resting state fMRI. What kind of networks are generating the complexity? What is the topology of it? What is the shape of the complexity? So this is all open and, of course, very challenging, but it's what we need to address.
Thank you. So thank you for referring to Olivia's work with our friends in Korea, and also again within the Human Brain Project, of using artificial intelligence, right, and deep learning, and these. Sometimes we tend to think about computers and their intelligence and would they maybe have some consciousness, which make me, Alain, question what are your thoughts on this? How smart are our machines now, and would we be able maybe to create an artificially conscious model on one of your machines?
Yeah, well, it's a very difficult question, but I could say that we would first need to measure, have a measure of whether a machine is conscious or not. And I think today we don't have one. We need, I mean, of course, they exist now. You have probably heard about Lambda, the new artificial intelligence from Google, which is absolutely remarkable. It's able to tell you a joke and figure out why it's funny and things. I mean, really sophisticated things. I actually don't know what the artificial intelligence would answer if you ask her. I think it's a her. If you ask her if she's conscious. I actually don't know, but I don't know even if it's relevant, because you could have told the machine to answer this question. So I think we need to develop really measures of consciousness that can be applied to not to machines, and so in a machine you cannot do a TMS EEG experiments to see if the activity propagates and if the brain functions in a conscious way. But I would like to say one thing is that a great feature in the HBP is that we also have access to animal experiments together with human experiments, and we have this in the same project, which is very rare. And we have mouse experiments, we have experiments in monkey, and in these, of course, in the animal you can do manipulations you cannot do in human, and really go further. And of course, with the caveat that the level of consciousness is different, evidently, in the animal than in at least the sophistication of the content of consciousness is probably different, because the language itself is an extremely important component of consciousness. And we have the chance of having all these together in the same project and being linked to both animal experiments and human, and go back and forth very quickly, because we are in the same project. And I think this is really fantastic. Of course, the HBP is almost finished now. We have 1 year to go. But I hope that this approach will be the seed for future projects, where we will continue to have this back and forth between experimental neuroscience in animals and human neuroscience and computational model to make the link, of course. This is our job.
Thank you so much for that, Alain. And that brings me, you mentioned that indeed HBP has been running for a while now, and thinking on what's next. And then I think we need to talk about Ebrains, right? And what you just mentioned is incredible added value of having guys working on animals and doing things, very precise, invasive measurements. And you already mentioned your own work, both of you, Marcello, Alain, and Steriad, and what that learned us and permitted the modeling, and then translate that knowledge to the bedside, which is where I'm, of course, very, very interested as a clinical neurologist also, to really now, for basically all European taxpayers, right, who have been seeing all the money going to scientists like ourselves and asking the question, okay, but what is the benefit? And I think it's very important we keep investing in mental health. 1 out of 3 Europeans sooner or later is going to be confronted with, being it a neurological or psychiatric disease. And we've seen with COVID, it's so important that we help people who are suffering from these different mental conditions, and that we translate all the knowledge generated by all the colleagues of HBP. And so to permit this to go on, I think Ebrains, this platform that will enable data sharing, and that all the guys in these wonderful labs within Europe can continue the good work. So this is a wonderful opportunity. I'm sure we all agree, and bringing me back to you, Marcello, on the challenges where you're developing these new methodological tools to challenge the theories. And we mentioned Giulio Tononi, medicine, integrated information. We have the Paris Global Neuronal Workspace. We have a number of propositions. I think none of them, but let me know your thoughts, currently truly explains how something material, and we're all looking at the brain, generates somehow subjectivity, thoughts and perceptions and emotions. So maybe could you guide everyone listening to us now on where we stand there? Where is the theory of consciousness today? And also, of course, with Alain, because this is, I think, something both of you guys have been thinking and dreaming about.
Yeah. So I think we're standing in a very interesting place right now, because on the one hand, we are, these theories that are making their predictions more and more specific, and they're also taking risks, of course. And on the other hand, I think also thanks, in my experience, really, to this long-term exposure that we had within Human Brain Project of two different theories, because I like to remember that within HBP, as you said, there are many different representatives, but there is this interesting fact that I think it's a positive sign. So there is a strong debate among theories, and sometimes they are pitched one against the other, and I think this is healthy and it's good. But at the same time, when you come together on a common platform and you are sharing the data and you start looking at data at the multi-scale level, you also find a lot of common denominators. And I think this is an added value of Human Brain Project, Ebrains, and the long-term perspective we have, because we are realizing that there is a lot of empirical convergence. Let me mention a few things. So, for example, there is a strong and significant agreement empirically that you need to measure something that is capturing the unity of the brain and the differentiation of the brain at the same time. And this has been done, for example, by the Paris group, and in Liège, the work with fMRI, the dynamic complexity of fMRI. Many experimenters within HPP are using complexity measures, for example, and they sort of work. So there is this interesting convergence in general on a set of measurement. And then, as far as theories goes, we will see in the next 20 years. What we can say now is that empirically there were ideas, and some of these ideas were stressing the importance of complexity. Complexity sort of works. It might be not the ultimate explanation, of course. It's a good measure. It's an advancement. It's something we sort of agree upon. But I think it's interesting, and it's promising. And really, I'm very happy about this empirical dialogue that we have, even if we come from different theories. I give you just one more example from HPP, the beautiful work by Matthew Larcombe. So this idea that there is a key mechanism, dendritic amplification, that might disrupt integration, feedbacks, and then complexity, as well as the idea that these off periods, actually first described by steroids, these silent periods in neurons, are important. Let's put these pieces together, and I think even by a mechanistic point of view, it will be an advancement.
Thank you. Alain, how do you use, so Marcello just summarized and made clear what the challenges are, and you in your models, how do you deal with this to go from theory to empirical measures and back?
Yeah. Before answering this question, actually, I would like to add the point to what Marcello just said, is that we had recently a series of conference on consciousness organized by HBP and the European Institute of Theoretical Neuroscience in Paris, and also in Rome more recently. And I remember I assisted at a conference on consciousness a long time ago, and it was you had the impression that all these theories that actually Marcello mentioned were so far from each other, and that we would never get them to agree ever, right? And this time in this late conference that was just a couple of months ago, we had also people like Christoph Koch from the Alain Brain Institute, who also is proposing something else. But for the first time, I had the impression that the distance between all these theories is getting smaller and smaller, and we are maybe reaching a point where we can formulate something that would satisfy everybody. So this is something that is not done, of course, yet, but I feel it coming, right? And I think it's an exciting time for those who are trying to model consciousness in this perspective, is that we feel that there is a unified, some kind of unified model coming. Now for your question of implementing models, what we have done in the last year, actually, we have used a lot of Ebrains in order to, we have integrated models that were designed initially from electrophysiology, so from intracellular recordings, from recordings of local field potential, really something invasive that is essentially coming from animal experiments. And we have recently integrated these models at the size of the entire brain. And so we have used, for this, we have used Ebrains. So we have developed in Ebrains models that are simulating using, I would say, biophysically informed models of local cortical columns. So those are population models. And when you put a lot of them and connecting, you have to find how to connect them to represent the brain. And so you have to, you have basically to take data from what we call the connectome. And the connectome is just telling you which part of the brain is connected to which. It's basically the connection matrix of the brain, if you want. And there exist connectomes for mouse, macaque, human, and so on. And in the Ebrains, it's very easy to do this because the connectomes are there. The simulation tools are there for doing it. For example, the simulation tool that is called the virtual brain, which allows you to integrate the model you like as a node and construct a network where the links will be given by the connectome. And so for constructing this, you need data from all over the place, if you want, right? And Ebrains is a great place because it has all this data available, and also the tools to develop the model. And actually, we have even helped Ebrains to develop better tools because we are users of Ebrains, and we told them, listen, if you start doing a model like this, you're stuck because this is missing, and so on. And so we have helped them to provide some interesting tools that we are still using today for building these models. And thanks to Ebrains, and I hope it will be useful also to many other researchers in the future.
Absolutely, and maybe also for the younger people, of course, we're not old yet, but those who start their careers and hopefully will be somehow inspired by this terrible challenge that understanding the brain and mind is, will use these possibilities and incredible European labs and Ebrains platforms to choose to what I think is the most beautiful job there is, becoming a neuroscientist and thinking and trying to understand your own thoughts, because I do believe we are different. Alain, you mentioned the big Google Lambda, where, is she conscious? And I think they even asked her, what are your thoughts? And she said something, yes, I sense some blue and whatever. But I definitely think, and when I reflect myself on, now 25 years of being confronted as a clinician to damaged brains and impaired consciousness, and working with you guys and these very, of course, smart people, and I wouldn't say smart machines, because I think they're very different from us, right? They they do not think, they do not feel, perceive. But correct me what your take is on that. But that we should not lose our own humanity. So we use these machines. I think they are not in any way comparable. They're in silico workings with our biological reality. And at one point, despite everything we've learned, and we did a number of things together, I think it's incredible to do that. And at the same time, you also somehow, despite the knowledge, are just looking at it with being appreciating the wonder of it all, right? When you see a child being born, or you see someone in a hospital bed, what do we really know about thoughts and perceptions and emotions, and how important it is to do this hard work and translate the knowledge and make it available to each and everyone. So to the young people who see this, if you would go back in time, Alain, Marcello, with everything you know now, what would you maybe recommend to the brilliant minds watching this now or later, who would like to, win a couple of Nobel Prizes and try to understand consciousness? So what do we need? What angle? You studied medicine, Marcello. You're from theoretical neuroscience, Alain, and the programming, so how do you see this? What is your advice for the young people watching us?
Yes. So first of all, is to go after the big questions. Don't be afraid. Don't think about your career too much. Go after the big questions. There are many big questions that are important for society and important for us all. So I think this is a work, and especially when you touch upon consciousness, that is huge implications in the clinics, that is obvious, but also for the way we see the world and the way we, act on the world. So just, you touched upon a very interesting, paradox. So you have on one side, as an artifact of technology, islands of brain, these patients that are difficult to access through behavior. Although we used to assess consciousness by analogy through behavior, if you behave like me, you are conscious, sort of a Turing test. It comes natural to us. But there are patients, due to intensive care medicine, that are maybe completely locked in, but conscious. So they don't behave at all. They are not. And on the other hand, technology is also building machine like Lambda. And we are getting confused just a little bit. We are not getting so much confused, but future generation might get really confused. If you keep looking at consciousness by a behavioral, functionalistic perspective, then there's going to be a problem for society. So we need to become more sensitive and more accurate in detecting conscious above and beyond behavior. This is, I think, important for society, for what we value, and for where we go in general in the generations to come.
Thank you. Alain?
So if I would have a message to give to young researchers, is that we need you. Whoever you are and whatever is your background, in neuroscience, we need people from every background. We need engineers, we need physicists, we need also mathematicians, we need biologists, we need philosophers, as we mentioned earlier. And actually, it's only by working with all these disciplines together, which only a single person cannot do, of course, but constructing teams that are highly interdisciplinary, and with people from many different backgrounds. I forgot also doctors. Sorry, you're both doctors.
I was about to comment.
I was sure I would be hit. And of course, doctors are almost at the first place, because they provide the root of the data we are trying to understand. we need all these disciplines to be put together. And as I said earlier, the great thing about Ebrains and big project like the HBP is that you have all these people in the same project, and so we can really make almost an infinite number of conferences by combining all these different disciplines, as we have done during the last 8 or 9 years. And I think it's great because, of course, we learn a lot from all each other, and also I think everybody feels he or she is contributing to the big picture. And so this is why my message to the young people is that just come to neuroscience and there will be a job for you, right? It doesn't matter where your discipline is from, right? There is a point in brain science where it's going to be needed.
Thank you, guys. I sum it up in kind of a call for rebels, right? For curious disruptors who do not accept what is in the books today. And I think, indeed, historically, we might have, I see it in my field, in severely brain damaged coma survivors, we've underestimated their capacity for consciousness. And I think the same is true for the newborn babies. When, Marcello, we were in medical school, we were still taught they're just unconscious, and we did invasive interventions without even giving painkillers. And the same holds actually for the other end of life, the elderly demented that no longer can communicate. We consider them vegetative, the term we now avoid, unresponsive, and that is very often wrong. Actually, also, Alain, you mentioned the very important added value of animal research. I think also with animals, because we cannot communicate with them, we've considered them also to be unconscious. And so this word becomes very difficult, even so that when we started this, as far as I'm concerned, in the 90s, we had difficulties to sell our projects and get funded because it was kind of taboo. And I think it's never good that as a scientist you have auto-censorship, right? We should go, as you said, Marcello, where the big questions are and invite all possible disciplines, as you say, Alain, to reduce our ignorance. So yes, please, everyone, you brilliant minds, join us. There's a lot to be discovered. We need you. We need Europe to be a strong player there. And I think we all agree it's a wonderful job. We feel very, very fortunate to be able to do that, to translate it also to the hospital.
And also we have this motivation of so many things we don't understand.
Yes.
So
and I think
it's absolutely a gigantic challenge for all of us. Yeah.
And bringing also, you're with theoretical neuroscience and the engineers to show them, that it's actually having an impact in our hospitals, and you see the patients and the families. But also maybe we should, what do you think, connect, because I now speak here from North America, where we have more interaction between the academic world and in the industrial partners. So maybe this in Europe could be stimulated more. I don't know what you think, but there could be more back and forth between possibilities to translate this knowledge again to products, to services. I know within HBP also, and Marcello, your EGTMS and the ways to quantify complexity. We work with this company from Israel, Neurosteer, where you have a very simple measure that just the way as we now monitor our heart rate, basically with a watch, we will in the future probably be monitoring our mental activity with these wearables. And so interacting with these guys, I think, is something we might within HBP and the European tradition stimulate more. I don't know if you want to comment or reflect on that.
Yeah, I want to say that actually HBP to me was a push, and it opened. Actually, I never realized that exploitation is important. It's a cultural problem. Maybe we have in Italy or in Europe, but I realized it through the interaction within HPP. For example, I learned from Victor Girsa, who was actually pioneering. I mean, he had this startup about epilepsy based on modeling, combining data with modeling, and that's, you know, that's way to go, because if you want to make, if things needs to happen, they want to happen, you know, on their own. You just, it's not enough to publish paper and to accumulate the H index. At some point, you have to put your neck on the line and try to make it happen. And that is exploitation. And there's nothing bad about it. Actually, it's good. And we just need to learn how to do it. And it's, I think it's a cultural shift. And I'm very grateful to the people in HPP and Ebrains, because they taught me that. There is an innovation team which is incredible, and I didn't know about it, and I've learned a lot, really. And I'm going to try because of that.
I think also you, Alain, are translating your knowledge and working with partners. I don't know if you want to say a short word about that.
Yeah, we actually started a company this year in converting slow waves into musical sequence, into sounds, and make people listening to their own slow wave activity under the form of music. And we found that this is efficient for relaxing, certainly, and for sleeping in some of the cases. And it was also helpful for patients suffering from chronic insomnia. And so we are starting now a company just to develop this application, because you just need the EEG, and the EEG you can record very easily, as you just mentioned. I suppose the Israeli company is an EEG recorder, right? And that the slow waves in sleep are something extremely easy to record, because they are high amplitude and so on. So it's something very simple, actually, to get the slow wave of a given person and give him or her the music corresponding to his own brain activity. And the company is called My Waves. And
we'll check that one out.
It's not yet at the state of commercialization, but I hope it will come.
And it's beautiful, Alain, because we started with Mircea Steriade in Quebec, who discovered the slow oscillation. And I think this is interesting for young people, just by opening up the filter of the amplifier, because these slow waves were not visible just because of the filter setting. And he discovered something that became crucial. And after 20 years, we're talking about this. It's very important. And
I remember there was an electronician, you remember him, Pierre Giguère. He modified the amplifiers in order to get the right frequency for slow wave, because the amplifiers were not made for recording slow waves. They were made for recording fast activity, right?
This is a lesson.
This is why Stead Lab was fantastic, because there were all this team of competence that came together. It was fantastic.
Thank you, guys. We need, because time is flying, wrap it up. But I think it's clear that scientists like ourselves, with the clinicians, with the partners from the industry, and I mentioned neurosteer, but there's also the brain-computer interfaces, and we have a wonderful company in Austria, GTech, that is actually the only one who's offering a plug-and-play device, the Mind Beagle, to try and communicate with people after coma. So it's wonderful to see that. I think our field might have been a little bit in coma itself, and now it's awakening. And I think wonderful technology is really having an impact in our European hospitals. That's it for me. I am gonna run back to the hospital. It's really been a pleasure, and I hope everyone with us enjoyed it as much as I did. Alain, Marcello, I thank you so much. For those who want to learn more, of course, your work is on the website HBP. Check it out in the comment section. And thank you, and thank everyone with us, and especially, of course, the organizers from HBP and Ebrains. Cheers.
Thank you.
See you next time.